Let's look at conditional probability. When you're playing Monopoly, what happens when you roll doubles? You get to go again. What happens when you roll doubles 3 times in a row? You go to jail. What's the probability that you roll doubles 3 times in a row? First off, probability is a number between 0 and 1 that we assign to the likelihood of a particular event. We will use the symbol P of E to represent the probability that an event E occurs. If E is impossible, then P of E equals 0. If E is certain, then P of E equals 1. We roll a 6-sided die. Find the probability that we roll an even number. Well, that would be 3 out of 6, because you could roll a 2, a 4, or a 6. So the chances are 3 out of 6, in other words, 1/2, that you roll an even number. Now, find the probability we roll an even number given that we roll a prime number. This is what we call a conditional probability. The probability of B given A is denoted this way, probability of B, and then that vertical line A. So in other words, this is the probability of B occurs given that A occurs. Probability of B given A is the probability of A and B all over the probability of A. Sometimes we use this terminology, probability of A, and that upside down U is intersection. Probability of A intersect B all over probability of A. That just means probability of A and B. That's all it means. So in this case, this conditional probability, the probability of B given A, probability even given prime, if we just apply that formula, plug in even for B and prime for A, we want to calculate the probability of even given prime. That's the probability of prime and even all over the probability of prime. All we're doing is plugging in prime for A and even for B. That's all we're doing. So the probability of even given prime is probability of even prime and even all over probability of prime. Okay, the probability of rolling a prime is 3 out of 6 because 2 and 3 and 5 are all prime. The probability of rolling a number that's even and prime is 1 out of 6 because there's only one number that's both even and prime, and that's 2. So that's 1 out of 6 over 3 out of 6, which simplifies to 1/3. That's the probability that you roll an even number given that you roll a prime, which makes sense because the only primes are 2, 3, and 5. And so if you roll a prime, well, there's a 1 in 3 chance that it's even because there's a 1 in 3 chance it'll be a 2. You pick 2 cards from without replacement from a deck of 52 cards. Find the probability that both are aces. Okay, again, we'd use this formula. Probability of B given A is the probability of A and B over the probability of A. And if you multiply both sides by the probability of A, you get a really cool formula. Check this out. You multiply both sides by probability of A to get probability of A times probability of B given A equals probability of A and B. Again, you multiply both sides by the probability of A, so that denominator is gone. And that equals the probability of A and B. So in other words, the probability of A and B is the probability of A times the probability of B given A. That's a handy formula. Probability of A and B equals probability of A times probability of B given A. So in this case, we want to find the probability that both cards are aces. So that's the probability that the first card is an ace and the second card is an ace. Based on the above formula, it's the probability that the first card is an ace, we'll call that A, times the probability that the second card is an ace, given that the first card is an ace. So again, second card is an ace, we'll call B, and first card is an ace is A. So all we're doing is plugging in first card is ace for A, and second card is ace for B, and this is what we get. Okay, so what's the probability that the first card is an ace? That's 4 out of 52, because there are 4 aces in the deck of 52. The probability that the second card is an ace, given that the first card is an ace, is 3 out of 51. Because if you pick that card without replacement, that means you don't put it back. So there are only 3 aces left in that deck of 51 remaining cards. So probability is 3 out of 51 that that second card is an ace, given that the first card is an ace. Multiply these fractions together, 4 times 3 over 52 times 51, and that's 12 out of 2652, which is about 0.0045. So it's roughly 1 in 2. There's a 1 in 200 chance that both are aces, roughly. Okay, what's the probability to roll doubles twice in a row? Again, the probability of A and B is the probability of A times the probability of B given A. Apply this in this situation, we get the probability of doubles in the first throw and doubles in the second throw. is the probability of doubles on the first times doubles on the second given doubles on the first. Now, realistically, probability of doubles on the second throw given doubles on the first, it doesn't matter what you roll on the first throw. The probability of doubles on the second is the same whether you roll doubles on the first or not. So we can just scratch out that. So yeah, that probability of doubles on the second throw given doubles on the first throw, that's just equal to probability of doubles on the second throw. So that means probability of doubles on the first times probability of doubles on second given doubles on first. That's just the probability of doubles on first times the probability of doubles on second. And this is 6 over 36 times 6 over 36, which is a 6 times a sixth. In other words, 1/36. That's about 0.03. Now, in this particular problem, because the probability of doubles on the second throw given doubles on the first is the same as probability of doubles on the second, we say that doubles on the first and doubles on the second are independent. In general, events A and B are independent if the probability of B given A is the probability of B. In other words, the probability of B is the same whether or not A occurs. So then what's the probability that you roll doubles 3 times in a row? Well, a moment ago, we saw that if it's 2 times in a row, it's just a 6 times a sixth. So in this particular case, it's doubles on the second, or doubles on the first, doubles on the second, and that last one should say doubles on the third. It says doubles on the second. Sorry, that last one should say doubles on the third. And when you multiply those together, it's just a 6 times a 6 times a sixth, or 1 out of 216, or 0.005. But it does happen. If you play Monopoly enough, you'll go to jail for rolling doubles 3 times in a row.